So hello everyone, my name is Pritam and welcome to another video. And in this video, we are going to discuss about recursion. Now, what exactly recursion is and why we should use it actually, and the fear of recursion in the industry people do have. We will talk about all these things, and I can guarantee one thing, that after this video, you do not need to think about it. Like recursion is a very tough thing. You will never say that. I can guarantee that. Watch this video till the end, and today I will give you the concept of recursion, how you should think to write a recursive function, and you can easily get it done after a few examples, after a few practicing, after a few codes. Like, it will be very easy for you to understand. Okay, and one thing, like, you should keep in your mind while watching this video, that recursion is not a tough thing. If you think mentally that recursion is a very tough thing, then yes, it is going to be very tough for you. But as I am instructing in this video, as the way, if you like try to understand those things properly, and after that, if you practice few problems which I will be giving in the sheet also, I will update, don't worry. And if you practice all these things accordingly, I will guarantee you nothing will happen, and you will be a master in recursive functions. Don't worry about that. Okay, so let's start. First of all, let me go to Gemini. Okay, a brief introduction to recursion using C. Okay, let's see what it says. Okay, so recursion in C is a powerful technique where a function calls itself to solve a problem. Just point to be noted, a function which calls itself. In the last video, we have talked about function call by value, by which, like, we can call any function from our main function, and that function will get some work done, and that's it. Okay, but here recursion is something else. Here it's like it's obviously a call by value will be there, or call by reference will be there, whatever it is. Normally call by value we will be using here, as we haven't covered the call by reference. So a function, a user defined function which we will be writing, that function should call itself. Then only we can call it's a recursion. Correct? A function which calls itself. Like here you can see a factorial is there, and here you can see the factorial function is getting called. Don't need to look into this logics and all. We will talk about it later on. But here you can see this is the one. If you see, this is the one. Okay. Here you can see factorial function is there. Here also the same function is getting called inside this function. That's why it is called a recursive function. Correct? So that is the thing. Now you should understand that if it is a thing, then first of all, how the function call actually will happen. So multiple times it will be calling itself, when it will be getting stopped. Correct? These kind of things will be coming up, right? For that, I will give you a brief understanding here. Okay, yeah. So यहाँ पर अगर तुम लोग देखो क्या हो रहा है, ये मेन फंक्शन है, ठीक है। यहाँ से f1 कॉल हो रहा है, f1 के अंदर क्या हो रहा है, f2 कॉल हो रहा है, f2 के अंदर क्या हो रहा है, f2 के अंदर f3 कॉल हो रहा है, एंड f3 के अंदर f4 इज गेटिंग f4 you can call. So f5, then f5, f6, ऐसे करके infinite times of functions you can call in a function and in itself. Okay, so function calling function is a different thing, and function calling itself, it's called a recursive function. Function calling another function, that's a common thing. जैसे कि main function is calling f1 the way we are doing it. Inside f1, f2 is getting called. Inside f2, f3 is getting called. Inside f3, f nothing is getting called here. f4 is not there. Okay, so how this is happening, that is the point. And if all these function names are same, then f1 would be a recursive function. Let me explain you. First of all, let's consider this a stack of books, for example. So we'll be instead of books, we will be using some functions here. Okay, instead of books, we will be using some functions here. So for example, I can write here like it's a f1. Okay, f1, then f2, and then f3, and this is the way. Okay, so f main function. Okay, first of all, let me talk about main function here. In what happens in memory. First of all, here it is a main function. Correct? Sorry, I am writing in PC, that's why it's very tough. I don't have the iPad setup as of now. Once it will be there, I think it will be easier for me to write very easily. Okay, we can use text box instead of that, I think. So it is a main function. Okay, so one second. Yeah, so here we can write it's a main function is getting called. Okay, so main function is calling what? F1. But what is happening, that main function is not finished yet. You can see there are two more lines are there. So obviously this function is not closed. Okay, this is open. So we have to put another one. Okay, just let's consider it's a book here, another book on that, another book on that, another book on that. That's why it is called a stack. Okay, it's a data structure actually. Okay, we will talk about it later on in the data structure playlist. But here you should understand this. Okay, so after that, what will happen? The F1 will be called. Okay, F1 is getting called, correct? So inside F1 you can see here number 3, line number 3 is remaining, but before that F2 is getting called. So here again F2 will be called. Okay, inside F2 you can see there are 5 lines, and in the line number 4 F3 is getting called. So here again F3 will be called. Now until the F3 entirely gets completed, okay, the cursor will not come to the line number 5 here like this. Okay, so once the F3 will be completed, then it will be gone, correct? It will be gone. So obviously F3 will be gone, then F2 will be coming up into the picture. Okay, so obviously line number 5, after once the F3 is completed, the cursor will come into the line number 5. Then after line number 5, F2 also is gone, it's completed, right? It will be vanished. And after that the cursor will come to line number 3 here, then F1 also will be done. And then after that, like, cursor will come to the main function. Okay, and then line number 4 and line number 5 will be executed, and then main also will be done. So that is how the function calling will be happening one by one. But in case of recursion, what will happen? In case of recursion, what will happen? It will come here, it will come here. The same blocks will be there one by one. Blocks will be generated, but the name will be same. Here F2, F3 will not be there. Only F1 will be there. The same code will be running up. Here it will be 3 lines. Here also it will be 3 lines. Here it will be 3 lines, not 5 lines or 4 lines. Okay, that's how the thing is. Okay, now we should think about it like that. Let me give you another example when the function will be coming as a recursive function. Okay, just a second. Let me take the screenshot and let me put it here. Okay, so here what is happening? I'm using any of the books, like it doesn't matter. So don't worry about that. Okay, uh, let me put it like that. Yeah, 1 second. Okay, so here what is happening? Here the main function is there, func is there. From func, it is coming here inside the func when n equal to func 5. After that, if you see here, func n minus 2 is getting called. That means the same function with a different value. Then n equal to 3 is getting called, and then n minus 2. So obviously n equal to 1 is getting called. So here all these things you can see, here this is called a winding phase. From here to here, here to here, and here to here. This is called a winding phase. Okay, winding phase of the recursion. And after that, what you can see here, that once it is done, like how it is getting completed, this is called the terminating condition. I was saying, right, how when it will be completed, like it can call in multiple times. It could be infinite loop as well. I will show you. But when it will be completed, when you can see here, if n equal 1, return. If n equal 1, return. A condition is there, right? This is called the terminating condition actually of the recursion. Actually, this is called the terminating condition. Okay, terminating condition of recursion. Okay, so this is the terminating condition or termination condition, whatever you say. After this condition, as it will be applied, it will say return is there. Okay, return is there. So return means it will come here. Sorry, it will come here, correct? And after that, like all these 2 lines will be completed, again it will be returning. Okay, that's the thing. So from here to here, 1 second, sorry. So from here to here, from here to here, and then from here to here, this is called the unwinding phase. Okay, unwinding phase of the recursion. And that's how it is actually. Okay, winding phase, when it will be dive in and then returning back. That is the unwinding phase. That's actually the recursion is. The code is exactly the same one you can see here. Okay, the code will be exactly same here, here, here. Just the parameter value will be changed so that we can call for multiple times. Okay, call the same function for multiple times. That is the basic difference between a normal function call and a recursion call. That's it. Nothing is there. Okay, let me tell you, like there are a few more things, like talking about the recursive function. Why would you need that? So how actually it happens that in recursion, okay, like we break the problems into several smaller problems. Okay, like for example, if you see here, okay, for example, here if I consider this is a bigger problem, we are considering like breaking into smaller problems. Okay, and then we are going to solve those smaller problems, which will be easier for us to understand. Okay, when it is about a complex problem, like it's better to break it down into several small problems, and accordingly you work on that. So solving a small problem is very easy rather than solving the entire problem on its own. That's why we are using recursion. Actually, it's nothing but you can consider one block will be divided into two blocks, it will be divided into four blocks, it will be divided into eight blocks, and then those eight blocks we can solve and we can retrieve the values, and in the main block the entire result will be coming up. That's it, nothing else. It's just the way to write the code. That's it. Okay, it's the way to write the code so that like your bigger problems will be divided into smaller problems, and those smaller problems you can easily solve by fewer calculations, and then you can return the things. Correct. Now let me give you an example like of the there are two ways actually to write the code. First one is iterative way, another one is recursive way. Let me explain you. For example, hash include stdio.h integer main. Okay, for example, if I write for example n equal to 10, integer n equal to 10, sorry. Yep, so for integer I equal to 0, I less than 10, I plus plus, I'm writing my name actually. Okay, Pritam Paul dot backslash n colon. Correct. Now here return 0. So if I run it, you can see 10 times my name will be printed out. But where we are using for loop, it is an iterative statement. That's why iterative way to write the code. But if I use a recursive code, okay, what will happen? For example, the same thing we can do here, and apart from that, we can call it like that. For example, void print name integer n, for example. Okay, if so, now in the previous code, what was there? Okay, in the previous code, what we are doing at that time, we are doing like here for I equal to 0, I less than 10, I plus plus. So the iteration value will be continuing from 0 to 9. Correct. So here n equal to 10. That's good. So integer n, n if n equal to 0, then we can do return. Else if it is not equal to 0, then we can print f Pritam dot backslash n. Okay, and after that we can call like print name of n minus 1. Correct. I will show you how these are the two different programs, and I will definitely I will show you that how these are actually the same code, but just the way of writing this is different. Okay, so here what is happening? So we are going to call print name of already 9 to for example, let us consider it as 9. Okay, so we can write n. That's it. So what will happen here for 9? Okay, it will be again 9 equal 0. No, then it is going to print out. Then for n minus 1, that means n will be equal to what? N will be 8, n will be decreased. So here you can see this is the initialization, this is the limit, and this is the increment. Okay, Here you can see this is the initialization, this is the limit, and this is the decrement. That's it. It's an incrementing way. Like if I write I equal to 10 and I greater than 0, or I equal to 9, you can write like this, I greater or equal to 0. The same thing will code will be same. Okay. Oh sorry, it will be I minus minus. That's the infinite loop is there. Okay. Yeah. So you can see 10 times it is getting printed out. Okay. For example, I would write, yeah, that is the way we can do that. And if you see here, okay, what it is happening, I equal to 9. So the same way, you can see these are getting printed out. Now, like what happens if we remove this? What happens if we remove this? Okay, you can see an infinite loop because there is no condition, no boundings. And I have to interrupt the terminal. And here again, if I write, you can see segmentation fault or something like that. It will be coming up obviously. So let me remove it and let me run this now. Again, segmentation fault is coming. Obviously, it will come. There is a separate reason, but basically it is the infinite loop because again, infinite like there is no like condition right here. What we have shown, there is a condition right where n equal to 1, then it is returning. There is no condition, terminating condition is there. Then again, like the function, the blocks will be getting generated one by one by one by one by one. So it will be going like a infinite list. Okay, so that's why. This is the basic difference. So then what you have to think about how you should write it. You should write think about basic problem. For basic problems you should write about only three things: how you are initializing, how you are conditioning, how you are decrementing. Now the printing statement could differ something, like if you give the it is below after getting call, then it will be something else. And if you print, like for example, let me give you an example. Like for example, here if I write percent d dot and then space, and then if I write here comma n, if you see, try to understand, see 9 then 1 is coming. Okay, now if I give it here, if you see 1 to 9 is coming. So that's the thing. The way we reverse the for loop here, like in the incrementing decrementing way, here it will be like that only. If you print it here, then obviously for 9 on n equal to 9, then 9 will be executed first and it will be printed out before calling the 8 n equal to 8 wala function. If you like put it there, then all the things will be coming up and then the printing will be starting in the unwinding phase. So if you are doing anything after getting called the same function, after the same function calling, then obviously it will be working in the unwinding phase. If you do it before, then it will be in the winding phase, as the way I was saying here. And this is the winding phase. In this phase, if you are printing before getting called, if you are printing anything, it will be printed in this part. And if you are doing after that, obviously in the unwinding phase, it will be working up. So that's the basic thing. Okay, that's basic recursion. That's it. Nothing else is there. It's very easy to like actually do it, right? So let me give you some other examples so that you can have understanding. For example, factorial. If I say, okay, factorial, or okay, let's take about the sum of n natural number. Okay, sum n dot sum n rec for recursion dot c. Okay, let me give you like what will happen. So the way we will be doing it, like first of all, let me write this main code. Okay, okay, so first of all, let me write this stdio dot h. Okay, and then let me write int main, then printf. Okay, that's it. Okay, I have to declare integer n for sure. Actually, writing codes in Python after like while no C में code लिखने में थोड़ा सा syntactual problem तो आता है. I hope you guys will understand that and forgive me for that. Okay, so yeah, that's the thing. After that, what we have to do. So how we are going to do that? Like sum of n natural numbers. So what we do normally for integer I equal to 1, I less or equal to n, I plus plus. We used to do like this, right? But here what we have to do? We have to write like this: printf percentage is the sum of percent d numbers. Okay, and here it would be percentage to the sum, then sum underscore n, we call it, and we can call for n, and it will be n. Correct. This is the function we will be creating. Okay, for n it will give the value, and this is the n, this is the this percent d. Okay, n natural numbers. Correct. Now right, return 0. Correct. Now here what we are going to do is int, as it is an integer, obviously it will be returning, so int sum of n of integer n. So how we have to do, when I equal to 1, obviously when I equal to 1 we have to return. Correct. So if n equal 1, what we can do, that we can return the n. That's it, we can return the n. Correct. But if it is not there, then what will happen? Obviously it will return n plus sum of n of n minus 1. Now from where I got this? That's the big question. Correct. Now if you see here, if I give an example, okay, like there are n natural numbers. Correct. For example, there are n numbers. Now, okay, let me use some other thing. Yeah, let me put this one, you will understand. Okay, so for example, the numbers are what? Numbers are 1, एक second. Here it would be 2, it would be for example 3, 4, 5, 6, 7, 8, and for example this. Okay, let me delete this one, we do not need that for example. Okay, I'm taking just an example so that you can understand how these things actually working, how we are getting the relations, how we will establish the relations. Just to explain that, I'm giving an example. Now we have to find the sum of all these numbers. Okay, the number is for example 9. Okay, so when 9 will be there, okay, when 9 will be there, then obviously n equal 1, obviously it will not return, it will not occurring. So what will happen? 9 plus sum of up to 8, that means all this value. Correct. Are we doing any calculation? No, we are just simply saying that that number plus all the other numbers, sum only we are doing. When n is equal to 8, then obviously 8 plus that one will be there. Correct. So that's the way we have to do. Correct. So when we are calling n equal to 9, sum of this, then obviously this another function, the new function which will be generated for n equal to 8, this function will give me the sum of this function will give me the sum of this function will give me the sum of this, and another function will be giving the sum of this, and then again this thing, these three, and then this two, and then this one will be coming up. So when n equal to 1, we can return not n, we can return 1 also. That's not a problem. Okay, we can return 1 as well. That's true. Yeah, we can do that. Correct. Let's run this. Enter a number, for example 10. See, 55 is coming. For example 9. See, 45 is coming. If it is 1, 1 is coming. If we are giving 0, then segmentation fault is coming up. So we have to take care of that as well. Okay. If it is 0, then what will happen? Okay. So we can do, my negative numbers is not possible obviously, but 0 is there. Okay. So we can write another one. If n equal 0, the return 0. That thing also we can do, or we can do here as well. 0 अगर हम लोग देते हैं तो यहाँ से डायरेक्ट रिटर्न 0 कर देते हैं. That's it. It depends on the business logic, how it would be implemented. It depends on that. We are not going into deep dive in how we will handle some extra side corners. Okay, that's edge case scenarios. We are not considering all these things as of now in this program. That's why I'm not using anything like that. Okay. But now if you write, for example, 0, 0 is getting handled, 1 is getting handled. For example, 34, you can see 595 is coming up. Like 1000, for example. So this is the one, the first one, natural numbers. As 0 is a whole number, I should not say in natural numbers. So we can write numbers only. That's it. Correct. So yeah, if you see, that's it. Of first 1000 numbers. So that is the way. From this one you have to find it out. Okay, from this one I have written. So this will be the terminating this is the initialization, something like that, or I equal to n, ulta bhi kar sakte hain, it's fine. So I got to know that from n to 1 it will be coming up, so n is getting initialized here. Okay, 1 we are setting up here, and this is the negative, like in the decreasing way we are doing it, that's why n minus 1, that's it, nothing else. Okay, so that's why we are not here writing minus minus n, because here it will be working, that's not a problem. Okay, sorry, here once again we can like minus 1, not like that, but why we are not like this, that n minus minus and then we are calling as a n, why we are not doing that? Because obviously we do not want the value to be changed, because after these things, like many might be this kind of calculations, or many more calculations might be coming up, as we have seen in this code also, like there are other lines after function to, many more lines are there. So if you are changing the value of n in this line, then how it will be happening? It will not be happening, correct? So that's why it is advisable then not to change the value. Okay, better you use n minus 1 like that, n minus 1 or n minus 2, something like that. Okay, let me give you another example. Okay, let's talk about some other problems, like for example, what should I give? Kya hai? Okay, sum of the digits वो करते हैं, that will be pretty good to understand. Okay, sum of digit recursion dot c. Okay, चलो, तो यहाँ पे क्या हो रहा है, हम लोग एक काम करते हैं, ये वाला पूरा कॉपी कर लेते हैं और यहाँ पे डाल देते हैं. Okay, so let's remove that. Sum of digits of percentage. Okay, okay, now sum of digit. Okay, let's do that, sum of digit. Okay, ना सम ऑफ डिजिट कैसे काम करेगा? सम ऑफ डिजिट के लिए क्या होगा, नंबर आएगा, हम लोग बार बार मॉड्यूलस करके उस चीज को निकालेंगे एंड उसके साथ बाकियों का रिटर्न कर देंगे. कैसे होएगा? नॉर्मली क्या होता है हमारे, हम जो फॉर लूप जब लिखते हैं तो क्या होता है, लेट मी अंडरस्टैंड दैट, लेट मी मेक यू अंडरस्टैंड दैट फर्स्ट एंड आफ्टर दैट वी विल डीप डाइव इन. ओके, सो नॉर्मली क्या होता है, व्हाइल लूप में होता है, ठीक है, व्हाइल एन होता है, दैट मीन्स एन ग्रेटर देन 0 होता है. ठीक है, उसके बाद क्या होता है, what we do, we used to write like this, that for example int digit equal to n modulus 10. Okay, and then we used to write sum plus or equal to digit, और उसको बाहर हम लोग इनिशियलाइज कर देते हैं sum equal to 0 करके. ठीक है, उसके बाद हम लोग क्या करते हैं, उसके बाद होता है n divide equal to 10, that means n equal to n divided by 10, करेक्ट? ओके, सो ऐसे करके ही होता है नॉर्मली. मेन ऑपरेशन क्या है, अपने को डिजिट डिजिट को प्लस करना है सम के साथ. ठीक है, तो we have to find the digit first and after that we have to call, like we are doing it using n divide equal to 10, that means n equal to n divided by 10. So what it will happen, for example, if it is 1 2 3 4 5, so for example 5 will be coming up, it will be adding up, and then 1 2 3 4, then 1 2 3, and then 1, and then 1, and then 0 0 में आके loop टूट जाएगा. That is the way we have to do, right? That's the way that dry run will be happening. So here let me write it down. Okay, first of all, if n equal 0, what we are doing it, we are returning 0, that's it. Okay, obviously it will return 0. Else what we are doing something like that, we are returning, okay, what we are returning, we are returning n modulus 10 plus sum of digit of what, n divided by 10, that's it, correct? So let me run this. For example, 1 2 3, see 6 is the sum of the digits. For example, 4 4 4 4 16, for example 8 8 0 9, for example 25. So that's the way it is, that's it. What we are doing, we are putting the like digit, and then the rest of the number we are summing. So that is why actually recursive functions, actually I found it like more readable codes rather than this while loop. If I show you here what is happening, it is be very tough to understand, whereas here we can easily see that we are putting the modulus here, that's not the right mode digit, and the left, all the rest of the numbers we are working the same thing. So the function actually is working with itself, actually we are not doing anything. That's the thing, that's the beauty of recursion actually. Okay, so this is the basics of recursion. I will share some more problems if possible in the end of the playlist. We will talk about some more difficult problems on recursion. Okay, many problems are there, and in the sheet I will update all the list of the problems which you need to revise and solve and understand how actually Fibonacci series works, how to check the divisibility by 9 and 11, like what is the GCD कैसे निकालना है, prime factorization कैसे किया जाता है. There are many more problems, and Tower of Hanoi is one of the most famous problems. When the iPad will be here after a month, I guess, after a month I'm going to buy. Let's see when it will be coming up. So I will discuss the Tower of Hanoi problem there, because it's very difficult to discuss using mouse and all. So that's the thing we will definitely discuss in the end of the playlist. It's little bit complex problems, but it's a very beautiful problem actually to understand recursion. Okay, and there are many ways actually to actually implement the recursion. Okay, and like tail recursion karke there is a topic. Tail recursion, actually tail recursion is something like which I already shown you, that here in this problem from the tail side it will be coming up. So sorry, not this one here. Like if you are putting all these things here, but from the tail set actually the work is going on. So that's what the tail recursion used to say in the unwinding phase if you are doing anything. Okay, but we will talk about that as well in some later video. As of now, to understand recursion, this is the basic thing. I will give some more problems in the sheet. Please try to solve them, and if you have any doubt, let me know in the comment section. I will definitely explain that code in a short or in a video. I will put the link there as well, here as well in the comment box. Don't worry about that. In the Instagram channel, you will get it. In the shorts I will be explaining the things if any issue is there, or here also I can upload, not an issue, but let me know in the comment section. Okay, and yeah, this much for today, guys. I hope you understood the recursion, basic understood. The fear of recursion should be come out of your mind. Actually, that is the main motto of this video. I hope it will be useful for you guys. Okay, and yeah, share this with your friends, and subscribe the channel if you haven't subscribed yet. Yeah, see you in the next video. Thank you so much.